Hi guys, my name is Parag and welcome back in the new numerical video of the steel structure. This video will explain you how you can calculate the efficiency of the joint step by step from start till end. Okay. Now this numerical is related to the tension member, and before starting this numerical I would like to ask you guys, please do subscribe my YouTube channel which name is Parag. Okay, and this channel will definitely help you for your regular growth in the civil industry. Okay, let's get started. So whenever you are doing any calculation, any understanding of any numerical, I would suggest that you should go through the numerical briefly. So the numerical is a single joint. See, this is very mentioned, a single joint. Okay, a single joint lap joint is used to connect two plates of 10 mm thick. So we have a very basic data available here. We have a single joint lap joint is already used. They already designed it. Okay, and it is used to connect two different plates which is having 10 mm thickness, right? Now there is a condition. If bolt of 20 mm is provided at 50 mm pitch, now they have provided the bolt of 20 mm as a diameter and provided at a 50 mm pitch, and they have also provided a pitch of 50 mm. Calculate the efficiency of the joint. So we need to understand the numerical. Whenever you are on the job, you need to also calculate the existing structure efficiency. You need to assess the structure. For that criteria, this numerical is totally belongs to you, right? Now we need to use Fe 410 plate and 4.6 grade of bolt. So this is a very interesting numerical, I would suggest, right? So the given data is diameter is 20 mm. So whenever the diameter is 20 mm or whatever it is, just add plus 2 to get the DO value and you will get 22 mm as a diameter of hole. Perfect. Now as I said, if you wanna calculate the area of the bolt, okay, the total area of that particular bolt, you can use the formula A and B. So A and B will help you to get that value of area of bolt by the formula 0.78 into Ag, which is 0.78 into pi by 4 into diameter square. So it becomes 245 mm square. Perfect. So 245 mm square is the value of area. Now let's go one by one. Just calculate the single shear strength of bolt. So to calculate the single shear strength of bolt, you required one formula which is VDSB. So VDSB is having a very standard formula, FUB upon under root 3 N into NB plus NS into ANS divided by gamma MB. But in this situation, we are only thinking about the normal shear. Okay, so FUB is a 400. We already have the 400 over here. Now you might thinking, sir, how 400 comes in? Because we are using grade 4.6. So 400 comes into picture as a FUB. If you not understand this, just go and watch my lecture number 1. You will understand how I have calculated this one, right? Now divided by under 3, 1, this is already there. A and B, we already calculate this area of 245 we placed here, right, upon 1.25 equals to 45,264 newtons. So this is our VDSB is calculated. Now just convert into the Newton. So this is a kilonewton, this is a Newton. Let me just make it in the kilonewton now. Okay, so 45.26 kilonewton we have over VDSB here. So this is our step number 1. Now if you moving to the step number 2, we need to understand, because we don't have any another data over here. Okay, now let's calculate VDPB also. Because there is no any concern related to design. This is related to the calculate the efficiency of the design. Okay, so bearing strength of the bolt we can calculate by VDPB, and we all are aware about the formula which we are using over here. VDPB equals to 2.5 kb into diameter of bolt into TP into FU divided by gamma MB. Now you all are aware that the kb value over here is having four different formulas, right? E upon 3 DO, P upon 3 DO minus 0.25, FUB upon FU and 1. Now all these four, among which the least value is the value which is referring to the value of kb. So whatever the least value among all these four is the value of kb. So now I'm considering the value of kb as 0.5. So I have 2.5, 0.5 is a kb value, okay. Then 20 is the diameter of bolt, 10 is the thickness of the plate, and fu is a 410 divided by 1.25. Right now you might wonder, sir, how 4.10 comes into picture. See, we have fe 410 plate over here, okay. Now after this you can see we get the value of Newton VDPB as a 82,000 Newton, which is 82 kilonewton. Now let's assume, because we have the pitch distance as a 50 mm over here, correct, but we also do require edge distance. You can calculate, you can make 2 into diameter. So diameter is 20, okay. So edge distance can be calculated by E equals to 2 into D, right. So 2 into diameter is how much? 20. So it itself become 40, correct. But you can see, guys, we are also considering the edge distance as a 40. If it is coming 37 or 38 like that, you should consider it as a 40, a nearest standard value, right. Now so you can see that we got the VDPB. Now let's jumping to the next step, which is the strength of net section per pitch length. Now why this is so important? Because we do want to calculate what is the strength of that particular area, the net section area per pitch length, whatever the pitch we have provided. Now this is a strength we usually calculate, but usually calculate from the with the help of the number of bolt and the what I can say, the VDSB. But in this situation we are to get the pitch value, but in this situation we are calculating the TDN, that means the strength of the section, by using all the value along with the pitch distance, right. So you can see usually we use this formula to calculate the pitch, but here we got a pitch, so we do require TDN. So 0.9 into fu in bracket pitch minus dn into thickness divided by gamma m1. So we got the TDN as a 82,656 Newton. Understand? Now our TDN is 82.65 Newton, kilonewton, right. So this is our TDN we got. Now the strength of joint per pitch length is 45. Why 45? Let me tell you one thing. Whenever you need to refer these two value, the first value is VDSB, second is VDPB. Now among which VDSB is having the value of 45 kilonewton, okay, and VDPB is having 82. So among these two value, whichever is the lowest, 45.26 is the lowest value, okay. So consider that value as the lowest. So this value is the lowest, 45.26. So this value consider as a strength of joint per pitch length, okay. To calculate the efficiency of the same, we need to calculate strength of plate per pitch length. Now we calculate the joint strength. Now let's calculate the strength of the plate. That is calculated by 0.9 into fu into pitch into thickness upon gamma m1. So 0.9, fu is 410, pitch distance is 50, and thickness is 10 divided by 1.25. So we got strength of plate as a 147.6 kilonewton. Now let's understand the efficiency. Now you can calculate the efficiency, and it is calculated by whatever your strength of the joint, this one value, which is lowest of VDSB and VDPB, understand, and the value which is strength of the plate. So both strength of the joint divided by the strength of the plate per pitch length, okay. This is very important, and multiplied by the 100, you will get the efficiency in percentage, 30.66%, right. So this is a step-by-step procedure to calculate the efficiency in the percentage, okay. I hope you like this video, okay. Understand this numerical again, okay, and you can watch this notes on www.civilnotes.com, okay, right. And I hope this video will definitely help you in future to get good understanding of the civil engineering aspects, okay. So thank you so much, guys. Have a nice day. Bye bye.